안녕하세요. 클라리네티스트 최재희입니다. 제가 방금 연주한 곡의 제목은 Just Out of Curiosity이고 이번 서울 디지털 포럼 2015를 위해 특별히 만들어졌습니다. 더 나은 세상을 꿈꾸는 호기심이 많은 모든 사람들에게 바치는 음악인데요. 이 곡에는 놀라운 비밀이 있습니다. 그 비밀의 열쇠를 가진 분을 소개합니다.
네, 여러분 프란시스코 비코 교수를 큰 박수로 맞이해 주시기 바랍니다.
안녕하세요. Thank you very much for this opportunity to communicate our work, and thanks so much for this wonderful performance also. When listening to this very piece of clarinet, people reported about feelings, about emotions that they have, like a bird singing, or an amusement park, these sort of things. And this would be just normal if it weren't for the fact that the author of this very piece never heard a bird singing. This never happened because it was a non-human intelligence. It was a computer named Mellomics 109. So what I'm going to talk now is about Mellomics, it's about genetics, it's about evolution, and it's also about music. I'm going to try to delve with two questions. How can we model creativity? How can we put that into the memory of a computer? How can we program that? And also, if computers become creative, will that change anything? How it will be if our computers can create by themselves? So, artificial intelligence is the field of computing devoted to creating intelligence. In a way, artificial intelligence is everywhere, we could say, because we always wanted to build intelligent machines. It is not so much in this type of humanoid robots that we were expecting, but more in specific, very specific pieces of software that solve concrete problems. But the thing is that from the many manifestations that we can see of intelligence, there is one that is particularly interesting for us, but also very difficult to model: creativity. Creativity comes from the brain, emerges in a way from brain activity, but we don't know very well how it happens. But if we think about it, we look a lot to nature. When we create, we are inspired by models taken from nature, not only physical things, but also behaviors. Indeed, evolution is one of the most creative forces that we know. But how can we embed this into a computer? Well, computers can simulate evolution, definitely. But the thing is that before we do that, we need something like a biological substrate. If we want to make something evolve, we need it represented in a way that can be evolvable in a way. So we need something like representing these objects in a sort of artificial genomes, very much like living beings. With a living being, we have a single DNA that specifies this particular species, and the design, the body design of it, and also the behavior comes in part from this DNA, from this genetic material. Well, if we have that in this situation, then we can perform evolution of objects, like, for example, these chairs, in a way that mutations and sexual crossover can be operating in the substrate, in these genomic representations of the objects, such that they evolve in time, and when they reach a concrete fitness, a concrete quality of design, then the evolution has been completed. Well, this is pretty much what we have done in music. So let's think for a moment that we can completely leave the process to the computer so that it automatically creates these objects. This has already happened in music. In 2012, IAMUS, a computer designed and programmed at the University of Malaga, was able to publish its first CD. This CD contained different pieces of work, scores, I mean, that were interpreted by musicians. But the new thing here is that these works were done without any human help. They were done from scratch. The computer was actually not mimicking any other composer. It was creating by itself. It was generating its own style. So for the first time, the computer didn't look at others, somebody else's music, but it invented its own style. So also a new thing at this point was that the pieces were considered good enough as to be interpreted by first-shelf musicians, like the London Symphony Orchestra. Let's listen to some of this music. So far, so good. So this was not really the type of music that you will expect. Oh, wait, just a second. This is not the type of music that you will expect in a discotheque, right? This is contemporary classical music, a very special style in classical music. But we wanted to go beyond that, and we thought, for people that is not trained in this particular kind of music, could it be that a piece of music that has been completely composed by a computer can move people, can inspire feelings? Well, we have found, performed a survey in collaboration with SBS here in South Korea with 500 persons. So what we did was to take two pieces, one made by a human composer, the other made by our machine, Mello믹스 109. Each one was commissioned to create a guitar ballad. That was the commissioning. And after that, both of them were commissioned to interpret each other's pieces. So we have 4 pieces, 2 of them made by the human, the other 2 made by the computer. And we distributed into 2 groups, such that one of them were listening to the human one, to the human interpreted and to the computer interpreted. So what we saw after that is that there was no real difference between them. If we were playing with old-style, old-fashioned computer music, let's say the 80s Casio tunes, then we will expect something like this. This will be the normal expectation, that everybody can make a difference between something that has been done by a human or by a computer. But what we saw in our experiment is that people had a hard time trying to sort them out. So it was basically like flipping a coin, 50%. So people really couldn't see a difference between them. Even musicians, professional musicians, the pink bar represents the opinion of professional musicians, people with more than 5 years of training in music. When they listened to the computer-interpreted piece, that was slightly different. About the same for non-musicians, but when musicians were listening to that, they were able to detect a little bit that it was computer-made. And that's fascinating. It's sort of musical Turing test that we conducted here in South Korea. And we also asked people before they knew that it was made by a computer about the the images that were represented in their brains, about the emotions, about what they felt. And we found out that they were having basically the same kind of emotions and images represented. As you can see in this representation, they were talking about natural phenomena like the sky or the sea or the wind, and about the same feelings like sorrow, happiness. So what we have demonstrated with this experiment is that a computer can actually develop something that moves people. But this is a paradox in a way, because music is a language to communicate feelings, but the computer does not have any feeling. It didn't mean anything with that piece, with that ballad. Okay, so let's see how the computer has learned in order to understand why this is happening. The computer, as I said, is not looking at somebody else's music, but instead is learning the rules to compose music from scratch. So it learns like a child. Every time the computer makes a mistake, the programmers and the musicians tell the computer not to do that again. And that's the completely new approach that we are using here. So let's see how the music evolves inside of a computer. So this will be the composition process represented in this kind of genealogical tree. So let's start from the bottom. As you can see at the beginning of the process, the pieces are very, very simple, just like bacteria were at the beginning of the evolution. But as we move forward, complexity increases because the genomes are somehow acquiring new material, new modifications. As they evolve in the computer's memory, and the musical genomes accumulate beneficial mistakes, the works become more and more elaborated. Eventually, it may end up in a melody which is quite familiar here in South Korea. You guessed it right, the SBS audio logo. But one key difference with the human way of composing is that, during the evolution, alternative paths have also been explored, creating possible versions of this melody, like this acoustic version. Or this one, in a more modern style. Or even this very rhythmic tune. So this illustrates how evolution operates on the genetic material of musical pieces as to obtain complexity from simplicity. But this bio-inspired technology also allows music genetic engineering. Specific songs can be created by manipulating the genetic material, intentionally mutating a rhythm gene, or inserting the melody gene of one of those logo variations into the genome of another song. Imagine the applications in marketing for creating brand awareness. Let's listen to an example. As we have seen, biological evolution can embed creativity into computing devices. Let's focus now on our second question. To what extent can creative computers transform the music scenario? Can we expect it to be a game changer, just like the iPod and iTunes were for the music industry? Firstly, having computers that compose massively will bring a dramatic reduction in production costs. Music will become a commodity, and anyone will be able to come up with a great song. Just like anyone can take a great picture, as digital cameras became affordable, photography transformed into a commodity. Even without the specific instruction, people make tons of pictures every day to share their experiences in the social networks. Could music become a way of expression for everyone? There are serious limitations to this. On one hand, the language of music is hard to learn, takes years of training. On the other, music is not out there. You don't simply record the symphony in the streets as you photograph the physical world. But if computers create that musical universe for us, then coming up with a great song will be only a question of searching in this space and maybe introducing minor changes. All in all, some sensibility and a good ear will suffice to produce music. Also, professional composers, instead of starting from a white page, will be able to browse this musical space in search of ideas, of inspiration. This will pave the way for new applications, like sound branding. Objects are designed as to be visually appealing, but forget other senses. How it will be if we could recognize a particular bottle of wine by a catchy melody, or if your identity jingle plays when a friend visits your homepage. That will sound happy or sad depending on your actual mood. On the other hand, music is more than entertainment. It interacts with brain activity and can heal. Indeed, music influences us a lot. It has the power to change our emotional state, to distract from whatever makes us feel unhappy, to increase our performance. However, recorded artistic music has little application in health. It focuses on entertainment and it always plays the same.
But how it will be if the same song will play differently depending on the person and her activity or physiological state? Sentient devices, as we have seen in the previous session, are growing fast, providing context information that can be used to adapt the music to the user's need. This is what we call empathic music, and it is provided by intelligent music players. Now, let's see how an empathic music player can help children and adults with insomnia. A smartphone can detect movement, and this correlates to some extent with heart rate and sleep stages. After placing the phone on the mattress, the song is attractive to capture the child's attention. Sometime later, if little movement is detected, the song will progress towards a softer, less percussive version. Finally, the song will become very much relaxed. But if the child suddenly turns around, the song becomes attractive again. That's how we do it when helping our children to fall asleep, empathetically. This is just an example of empathic music, but applications are endless, alleviating chronic pain, increasing concentration, and relaxing before an exam, or even adapting the music to the traffic conditions. All this is just an ongoing revolution. It's currently happening. Computers have been creative, and they are building for us this music universe, democratizing composition, making of it a new way of expression for everyone, and empowering the new technologies for music enjoyment and helping people.
Well, I would just like to thank you for this opportunity to come here and talk about all these things. Computers definitely have become creative, and we have to be ready for that. Kamsa, thank you very much.